Solving radical equations with rational exponents. If an expression is raised to a rational exponent, we still follow all the same steps as before, but with one slight adjustment. So now we're going to be using what we learned in the very first podcast in this unit, which was nth roots. So here's our steps. Just like before, we're going to isolate the expression raised to the rational power. We're going to raise both sides of the equation to the reciprocal of the rational power. Right? So, for instance, if you had a square root, the reciprocal, so square root, if this was my radical, is a square root, right? That's equal to 1/2. Right? What would undo 1/2? Squaring, right? Squaring undoes a square root. Right? So we're going to use the reciprocal exponent to undo our exponent. Then we'll solve just like any other equation, and we'll check all our solutions by substituting into the original equation and simplifying. Sometimes we'll have to rewrite something that's in a rational exponent, change it into a radical because it's easier to evaluate. Right? These actually aren't really that difficult once you get the hang of it. So let's take a look at our first one. Right? So we have 3x plus 2 to the 1/3 power plus 1 equals 0. Right? No need to change that to a cube root. We can solve it using the steps for equations with rational exponents. So we're going to our first step is to isolate the expression with the rational power. By the way, all of these are in your notes. Right? So there's only one thing we need to do, and that's subtract 1 from both sides. Right? We need to move the 1. So now we have 3x plus 2 to the 1/3 is equal to -1. Right? So now we're going to raise both sides to the reciprocal of the rational exponent. So we're raising this. What's the reciprocal of 1/3? The reciprocal would be 3/1, which is just 3, right? We don't really need the 1 in the denominator there. When you write 3, you don't put 3/1, you just put 3. We have to do the same thing to the other term. Right? So our next step, to raise both sides to raise something to raise to a power, that's the power rule. So you should put this in your notes. Power rule. And this would be a review from Algebra 1. To raise an exponent, or a term with an exponent. Or actually, let's put an expression, because it doesn't have to be just a single term. An expression with an exponent to a power, you just multiply exponents. And this is actually something we're going to use several times this year. Actually, this semester. You just multiply exponents. So to raise power to a power, you multiply exponents. So for instance, this has nothing to do with the problem up there, but just a little explanation. So for instance, if I had x squared and I wanted to cube that, that would be x to the 2 times 3 power, or x to the 6 power. Now, to help you see why that's so, if I'm cubing x squared, means I'm multiplying x squared by itself 3 times. How many factors of x do we have? We have 6 factors of x. Right? But instead of having to expand it, right, and then add up the exponents to raise power to a power, we could just multiply the exponents to make it easier. Right? So you should put this in your notes somewhere or on a little sticky. Power rule to make sure that you understand this concept and why we're raising our expression here to the 3rd power. All right, so now we're going to multiply. If we multiply exponents, 1/3 times 3, that's just going to be 3/3 or 1. Right? So now we don't have an exponent over here. This is just 3x plus 2, and that's it, equals. And all we have to do now is raise negative 1 to the third power. Well, what's negative 1 times negative 1 times negative 1? Well, it's negative 1. And now all we have to do is solve for x. Right? So once we raise this to the reciprocal power, it gets rid of our exponent and makes this a super easy problem to solve. We'll just subtract 2 from both sides. So we have 3x is equal to negative 3. Divide both sides by 3, and x is equal to negative 1. Always we have to check our solutions. So for radicals, whether it's written as a radical or it's written as a rational exponent, you got to check your solutions. All right, so here's our check. I think I can squeeze it in here. So we have 3 times negative 1 plus 2, and that's to the 1/3 power is equal, plus 1, excuse me. Plus 1 is equal to 0. All right, so let's rewrite that 1/3 power there as a radical. All right, so the 3 would be the index, 1's the exponent, but I really don't need to raise something to the 1 power, the first power. Right? So we'd have negative 3 plus 2. Did I lose? Oh. Did I lose somebody? No. Oh, okay. Never mind. Never mind. Some reason I was thinking I put in there positive 3 plus 2. I put in negative 3 plus 2. And I almost thought I said that doesn't make any sense. That won't equal 0, but yes, it will. I just looked too quickly. I am just going to expand my screen a little bit so I have a little bit more space. Hopefully on the next problems I gave myself 2 pages. And so this would be, who knows, maybe I gave myself 2 pages on this one. This would be the cube root of negative 1 plus 1. Well, we know the cube root of negative 1, that's just negative 1. And negative 1 plus 1 is 0. So that one checks out. That's a good solution. Let's give him a smiley face for checking out first. Right? And I'm just going to see if I gave myself room to check. No, I did not. So it's a good thing I squeezed it in. All right, so that's really all we have to do in these problems. We're going to isolate the expression that's raised to a power. We're going to raise it to the reciprocal power because our goal is to have our expression raised to the first power. And then you don't need the exponent. You don't write things to the first power, right? You just leave that off. And that enables us to get rid of those parentheses, and then we can just solve for x, and then we'll just check and make sure our solution is good. Right? And we can do all of this thanks to the power rule. So now let's look at our next one. Right, so we want to isolate the expression with the rational power. Right, so when you're isolating, make sure you add and subtract first. So we're going to add 2 to both sides. If I divide by 3, I'm going to have to divide everything by 3. Right? The negative 2, the 0, I don't want to do that. Let's just isolate the 3 times the radical expression there, and then we just have to divide each side once by 3. All right, so this is going to be 3 times 5. That looks like a 6. 3 times 5x minus 1 to the 1/3 power equals 2. Now we'll divide both sides by 3. So we have 5x minus 1 to the 1/3 power equals 2/3. And now to save ourselves a little space, instead of writing this again and raising it to the power, I'm just going to raise it to the power right now. Right? And we know that the reciprocal, because we just did this on the last problem, the reciprocal of 1/3 is 3. And we don't really need the 1 in the denominator there. So we're going to raise that to the 3rd power. If we do it to one side, got to do it to the other. So we're going to raise that to the 3rd power. Okay, and so now we'll continue. All right, so now 1/3 times 3, that's just 1. We don't need an exponent of 1 anymore. So this is just 5x minus 1. Got to raise the other side to the power. If you have a fraction and you're raising it to a power, just raise the numerator and the denominator. So 2 cubed, that's going to be 8. And 3 cubed, that's 27. Right, so now we're going to need to isolate x. Right, so we'll add 1 to both sides. Now on this side, though, we can't just add 1 to 8 27s. Right? So we're going to have to change that 1. So it still equals 1, but we can combine it with the 8 27ths. And what number would that be? Well, of course, it would be 27 27ths. We can add those two together. So this is going to be 5x is equal to, so that's going to be 35 27ths. And now we have to divide both sides by 5. But if you've got a fraction, don't divide by 5. You're likely to make a mistake. Instead, what do you do when you want to divide by a fraction? You multiply by the reciprocal, right? So instead of trying to divide 35 27ths by 5, we'll just multiply it by the reciprocal. We'll multiply it by 1/5, and that will be a lot easier. All right, so now we'll just finish off simplifying. And by the way, if you have more than one color pen like I have here, that might be helpful so that you can see the different steps. You can see that we put 2 steps in one where the green and blue is. We put 2 steps in one where the green and red is. So 1/5 times 5x, that's just x. I could multiply the 27 times the 5, or I could just reduce first. You can, when you're multiplying, you can reduce numerator to denominator. Right, so both of those are divisible by 5. 35 divided by 5 is 7, and 5 divided by 5, that's just 1. That gives me something a little bit smaller to work with, and I'd have to reduce anyway. So now I don't have to reduce. So my answer is 7 27ths. Now let's check our solution. And we'll check it over here, because I didn't do any writing on this side of the board. I've got plenty of space to check. Right, so we've got 3 times 5 times 7 27ths minus 1, all raised to the 1/3 power, minus 2 equals 0. Okay, and so now let's simplify. So we've got 3 times, right, so 5 times 7 27ths, that's 35 27ths. Let's change the 1 to 27 27ths. That's all raised to the 1/3 power. Then minus 2 equals 0. Let me fix that 1/3. That looks a little wonky. There we go. All right, so now we can combine our terms there. And maybe at the same time, let's change this to a cube root, because it's a lot easier to evaluate when it's a cube root than a rational exponent. All right, so 35 minus 27, that's going to give us 8. And we have 27 in the denominators. And I don't know why I made the radical that large. It's just a single number. And then we have minus, so we're going to multiply first, right? And then minus 2 equals 0. Order of operations, we would multiply first. Actually, excuse me, we would simplify the radical first, then multiply, then subtract. So 8 27ths is actually a perfect cube, right? We know that because we cubed 2/3 to get 8 27ths. So this would be 3 times 2/3 minus 2 equals 0. Well, 3 times 2/3, the 3 is going to cancel. And that just gives us 2 minus 2, which is indeed 0. And so that one checks out very nicely. And our answer gets a smiley face for being a good solution. Right, 2 down. I think there's like 5 or 6 total. Oh, and I gave myself lots of space. I gave myself space to check, didn't I? Isn't that the exact same problem? Yes, it is. Well, I didn't need it on the other page. I checked it fine on this one. That's one less page. All right, let's continue on. So we have 2y plus 6 to the 1/4 power minus 2 equals 0. We need to isolate our something with the radical there, with our rational exponent. So we're going to add 2 to both sides. So we have 2y plus 6 equals 2. All right, so now we're going to raise it to, to the 1/4 power, equals 2. And so now we're going to raise that to the reciprocal power so that we can eliminate the exponent and free our expression. Right, so the reciprocal of 1/4, that's just 4. All right, so we're going to raise both sides to the 4th power. And so we'll just combine those two steps. All right, so when we multiply 1/4 times 4, that's just going to be 1. Right? If you take a fourth of 4, you just get 1. All right, so that would just be now 2y plus 6 equals 2 to the 4th power is 2 times 2 times 2 times 2. That's going to be 16. And now I just need to isolate y. So the solving on these, once you've, I mean, the hardest thing is maybe raising to the reciprocal power. And that wasn't that hard, was it? No. But now the solving, that's pretty easy. We're going to subtract 6. We got 2y equals 10. And then you're dividing 10 by 2. How much easier could that be? Y is 5. So let's check our solution. All right, so we've got 2 times 5 plus 6, all raised to the 1/4 power, minus 2 equals 0. All right, so that's going to be 10 plus 6 to the 1/4, 1/4 power, minus 2 equals 0. When we add those together, let's rewrite that. Right, so if we have our exponent is the 1/4 power, we know that is a 4th root. Right, so the 4 in the denominator there, that's the index on our radical. I should probably make that a little smaller. That's the index on the radical, and we're raising it to the 1st power, and you don't need to raise something to the 1st power. So you've got the 4th root of 16 minus 2 equals 0. Well, what's the 4th root of 16? Why, we raised 2 to the 4th power to get 16. This is just 2. 2 minus 2 equals 0, and 0 equals 0. That checks out. And so another happy face. Another good solution. And so it gets the happy face. Right? So hope these are making sense to you. Right? And as always, if you have questions, ask me in class. The steps really don't change on these. The only thing I can do is give you a harder exponent. So now, none of these 1/4, 1/3. Now I got 2/3 in here. Ooh, a little harder exponent. All right, so first step is to isolate the expression with the rational power. All we got to do is divide both sides by 2. That's the only other thing besides the expression that's raised to that rational power. So we'll just divide both sides by 2. That gives us x minus 2 to the 2/3 power equals 25. We need the reciprocal of 2/3. That's just, whoops, there it is, 2. 3/2, right? Just flip it. So we're going to raise both sides to the 3/2 power. Now before, we had easy exponents. I mean, we're just raising something to the 3rd power. We were just squaring something. Now we got something a little more complicated. We're going to have to rewrite that to be able to simplify that. All right, so of course, 2/3 times 3/2, well, that's just 6/6. That's 1. Right? So you have x minus 2 to the 1st power. No reason to put that exponent in there. Equals. Now we want to rewrite this. I'm going to put a little note here. Rewrite into radical form. It didn't matter on the others at all, right? We didn't even have a radical, right? We were raising it to an integer. So rewrite into radical form. All right, so remember, this is it's always power over root is our rational exponent. Right, so that 2 there, it's a square root. We don't normally write the index on a square root. It's understood, no index, square root. And now we have the square root of 25 cubed. We shouldn't cube the 25 first. Nope, we should take the square root. It's a perfect square. X minus 2 is equal to square root of 25. That is 5. So now we got 5 cubed. Now that's easy. So we just have one little extra step here when we have an exponent like 3/2 that we're raising in number 2, right? We want to rewrite it into radical form. We'll simplify the root. Then we can just raise to the power just like before. So we have x minus 2 equals 5 cubed. 5 times 5 is 25. 25 times 5, that's 125, right? Because 4 times 25 is 100. Right? That's like 4 quarters is $1. Add one more 25, that's 125. So x minus 2 is 125. Add 2 to both sides. So x is 127. Of course, we're going to check our solution and make sure it is a good one. All right, so we've got 2 times 127. Oh, so, yeah, 127. My shadow keeps blocking me, so I can't see. To the 2/3 power equals 50. And always go back to your original. Right? You don't want to go back into any step you simplified, right? Because if you made an error on the first step and you try to, substitute some other step, you won't know you made an error. All right, so we've got 2 times 125 to the 2/3 power equals 50. Now we're going to want to rewrite that. All right, so remember the denominator is the index and the numerator is the power. So this is going to be 2 times the cube root of 125 squared equals 50. And we're going to want to take the cube root first. Right? We know it's a perfect cube. We cubed 5 to get 125. Right? So the cube root of 125, of course, that's 5. 5 times itself 3 times. That gives us 125. So we have 2 times 5 squared equals 50. Got to square first, order of operations. So we've got 2 times 25, and that indeed does equal 50. Another good solution. Happy face to you, Mr. 127. You worked out perfectly well. So far, so good. No extraneous solutions. These have all been good solutions. All right, so let's continue on. I don't remember how many there are. Here's our next one. We have x plus 9 to the 5/2 power minus 1 equals 31. So we're going to isolate this guy here with the rational exponent. All we have to do is add 1. Not too difficult, right? And then we'll rewrite it, we'll raise to the reciprocal power, right, so that we can solve it. So we have x plus 9 is equal to, to the 5/2 power is equal to 32. Right, so now we're going to raise that to the reciprocal power. I can move that down just a little bit. I can. Right, so the reciprocal of 5/2 is 2/5. You just flip it. All right, so we're going to raise both sides to the 2/5 power. Again, we're going to need to rewrite this 32 into, oops, that's supposed to be a 5. There we go. And we're going to rewrite as a radical. So we have, of course, 5/2 times 2/5. That's just 1. So there goes our exponent. So we have x plus 9 is equal to, all right, so we're going to rewrite this. Denominator is the index on the radical. And the numerator is the exponent. All right, so I know what the 5th root of 32 is, but what if you don't know what the 5th root of 32 is? Here's how you can find it out. Right? So this is called, what if you don't know the 5th root of 32? Use the buddy method. just like before when you were learning how to simplify radicals or square roots. You just need 5 factors, right? So what number divides evenly into 32? Well, a good choice would be 2, right? Right, so 32 is divided by 2 is 16. How about 16? Well, that's 4 times 4. Right, well, 4 and 4, those are prime numbers. You can break those down to 2 and 2. Right, so take a 5th root, 1 comes out, and guess how many go away? 1, 2, 3, 4. Right, because we need 5 factors to take a 5th root. So the 5th root of 32, why, that's 2. So we have x plus 9 is equal to 2 squared, and 2 squared, that's just 4. X plus 9 is equal to 4, and we'll just subtract 9 from both sides. X is equal to -5. Now let's check our solution and see if it's a good one. Right, so we have -5 plus 9 to the 5/2 power minus 1 equals 31. So that's going to be 4 to the 5/2 power minus 1 equals 31. Let's rewrite that as a radical. So the 2 in the denominator, that's our index on our radical, so that's a square root. Right? And so we've got the square root of 4, and that's raised to the 5th power minus 1 equals 31. Square root of 4, that's 2. 2 to the 5th power, you know this now. That's 32. And 32 minus 1, I do believe, that's 31. And another good solution. Happy faces to you, Mr. -5. I wonder how many more we have left. Probably not too many. And you notice here, the steps are pretty much all the same, right? Isolate the expression with the rational exponent. Raise both sides to the reciprocal power. I mean, sometimes you may have to do something a little extra, like rewrite as a radical, or you have to square something. But overall, same steps for each one of these. Here we go. Here's our next one. No isolating here. So let's just put a little NA here by step number 1. Not applicable. It's already isolated. So now we're going to raise both sides to the reciprocal of the rational exponent. If you notice, I never changed those steps that were written here. I just put an NA for the first time by number 1. Reciprocal of 3/2 is 2/3. Right, so we have x minus 4 to the 3/2 power, and we're going to raise that to the 2/3 power equals -8, and of course that's also going to be raised to the 2/3 power. Right, so now if we multiply 3/2 times 2/3, why, of course, 6/6, that is 1. Right, so this is now just x minus 4, because nobody cares that it's to the first power. You don't need that. Of course it's to the first power. There's 1x minus 4 there. Right, so now we're going to rewrite this expression, this term here, into radical form so that we can evaluate it. Much easier to evaluate in radical form. So always change to radical form. There are reasons, by the way, to have rational exponents. You can do some things with rational exponents. You can use the rules of exponents that you can't use with radicals. But evaluating, easier as a radical. So, of course, the denominator, the 3 there, that's the cube root of -8 squared. So we have x minus 4 is equal to the cube root of -8. Why, that's -2. We've seen that one before, squared. So that's going to be x minus 4 is equal to -2 squared. Don't forget to square that negative. That's going to be 4. And then we just add 4 to both sides. So x is 8. Let's check our solution. All right, so we've got 8 minus 4 to the 3/2 equals -8. Right? And so now we're going to rewrite that. We'll simplify it as 4. We'll rewrite that as a radical. So the 2, that's the index on the radical. That's a square root. And then we have the square root of 4 cubed equals -8. Square root of 4 is 2. So that would be 2 cubed which is starting to look a little like a 23. 2 cubed, yeah, be careful with your exponents that you don't make them as large as your numbers. Otherwise, you'll get confused. Equals -8. Well, 2 cubed, that's 8. Oh, and that is not a true statement at all. So here, did we know? Well, we know it's not the same. And this is an extraneous solution. It does not work out. We did everything right. We didn't make a single mistake. You can look, not a single mistake there. But we got this extraneous solution. How can we make not a single mistake and get an extraneous solution? Do you think you know before I tell you? It happened right here. When we squared that -2, we made it positive. And it gave us an answer, but it gave us a false answer. There isn't anything that we could plug in for x that's going to give us -8 on the other side. Oh well. Thanks to that square, right? And if you think about it, this was a square root. Could we take a square root of a negative number? No. So just because you get a negative doesn't mean it's not a solution. But in this case, this was not a solution here. Not a solution at all. Extraneous, right? So if you're not sure if you're not a solution, it's not a solution, look at your steps. Do you see any mistakes? If you don't see any mistakes and you're still not sure, come ask me. I'll tell you if you were right or not. But that is, we did everything right, but that is an extraneous solution. So there are no solutions here. And so, Mr. 8, you're going to get a sad face. And that's our last problem. So we end on a no solution. Oh well, we have to have one of those, right? Just to show you, you always got to check. Because just because you do everything right doesn't mean your solution's any good. These are problems already posted on Schoology. And so go ahead and solve these problems. And that's what we're going to be working on in class tomorrow. So thanks for watching my podcast, and bye for now.